Good morning, and thank you for tuning in for some more learning. At this point, we are going to move on to 1.3, maximum or minimum of a quadratic function. This is a great question here, number 5, and it sort of spans the page, so I'll read it for you. Because it's going to involve completing the square, but first we need to create a quadratic equation that's going to represent this situation. So a hall charges $30 per person for a sports banquet when 120 people attend. For every 10 extra people that attend, the hall will decrease the price by $1.50 per person. So what number of people will maximize the revenue for the hall? All right. So here we have a line. This is going to create a line. $30 per person, but that number is going to drop as more people come. Okay, so there we need to first create a linear equation and then multiply that by the number of people to find out the revenue. Okay, so let's take a look at that. We would have here number 5, revenue is equal to number of people multiplied by cost per person. And that should make intuitive sense. That's just like how they're going to make money. Okay, now number of people, well, let's let x equal the number of people, because we don't know yet. That's what we're looking to find, and that's a real clue in the question. What number of people will maximize the revenue for the hall? Okay, so there's going to be some number of people. We don't know it yet, so let's let that number be an x, and then we'll find it. That's the real clue for our let statements, is this, like where they finally get to a question mark. That's where you're going to make your let statement. And then we can, see, well, revenue is going to be equal to x, number of people multiplied by the cost per person. Now we want to know, like, well, okay, we could have the cost as a function of x, and that's going to be some linear relation. Okay, and the linear relation, they're going to decrease the price by $1.50 per person. So the cost is going down as the number of people goes up. So we know that, negative 1.50, that's a negative $1.50 multiplied by x. That's going to be something that's operating on this cost. But the cost is set at some value. The cost is some value b, right? And we don't know that b yet because they haven't told us. But what they have told us is that they're charged $30 per person when 120 people attend. So that's actually a point. So let's write this point down. It's actually a point on C of x. So we would have the cost when 120 people come is equal to $30 per person is equal to 30. Okay, the cost at 120 is equal to 30. So this is actually a point. That's the point 30, 120. Or I'm sorry, the other way. 120, 30. When I have 120 people coming, the cost is $30 per person. That's just information I'm reading from the question. So I can have this point as one of my points on this line. Now I can use that point to solve for my b, because here I have too many unknowns. I don't know the value of the function, I don't know what input, and I don't know what this initial cost is. What's the cost per person when there's 0 people going? All right? But I can use this to find that. So let's do it this way. So C at 120 is equal to 30. So let's bring this down. We know 30 is a nice number. We can work with that. But let's put this on the other side here. Negative 1.5 multiplied by x, but I'm told my x is 120. Plus some value b is equal to 30. So now work this out. Negative 1.5 times 120, that's going to be negative 180. Your calculator will tell you if you don't know. Plus b is equal to 30. All right, and let's move that over. Whoop. So to move that over, we're going to add 180 to both sides. This is usually how I will write that down. Add 180, add 180. So I have b is equal to 30 plus 180. B is equal to 210. And what that's telling me is that this hall will charge you $210 per person when 0 people attend. Okay, so it's very expensive when 0 people come. If 120 people come, then the price is already down to $30. The price drops very fast the more people come. All right, so that's all the information that we've got. Therefore, the cost, which is a function of x, is equal to negative 1.5 multiplied by the number of people plus 210. Circle that. That is what we're going to put in up here for the cost per person. So I know that revenue now is number of people times cost per person. So let's write out a revenue formula. Revenue is a function of the number of people that come. It's equal to the number of people that come multiplied by C of x. X times C of x. Okay? C of x I can write out. It's this. This is equal to x multiplied by negative 1.5x plus 210. Okay? Now, we have this function already in factored form. So we could use that to find the two zeros, and then we know that the maximum value is going to be right in between those zeros. This is one method that we could solve this question, where I would have one of my zeros would be at x, and one of my zeros would be where this becomes 0. So if I solve by finding zeros, then what I'm doing is I'm saying I know that this is a parabola and it opens downwards like this. The maximum is going to be there, and the two zeros here are symmetrical around that point. So I would take the average x value there and then solve the function for y, and that would tell me where that is. So I would know that if, so I'm looking for the zeros, so then I would say when Rx equals 0, then I have these. So that's 0 equals x multiplied by negative 1.5x plus 210. Okay? Now, I know this could be 0 when x is 0, and that's this 0 here. And that should make sense. If 0 people come, their revenue is 0. They have no one to charge, so that's one of their zeros. The other 0 is where so many people come that the price per person has been reduced to 0. And that's here when this term becomes 0. Okay? So that's going to be either x equals 0 or negative 1.5x plus 210 equals 0. Okay? So now, where does that equal 0? Well, let's move this to the other side. 210 is equal to 1.5x. So divide both sides by 1.5, and I get that 210 divided by 1.5 is 140. So check your calculator and you'll find that's true. 140 is equal to x. Okay? And that's just, I divide both sides by 1.5. So there, now I know that this is at x is equal to 0, and that's at x is equal to 140. So the maximum value that they're going to get is where 70 people come. It's right in between those two. 0 plus 140 divided by 2 gives me an average of these 2 points. That would be at x is equal to 70. Then to solve what's their maximum revenue, well, actually, I was just asked what number of people will maximize the revenue for the hall. So I have actually solved the question now. It's 70 people. If I want to know what that maximum revenue is, I would say number of people multiplied by the cost per person. So that would be negative 1.5 times 70. So that would be negative 105 plus 210. So the total cost per person is 105. So $105 is what people are paying when they come, and then I multiply that by x, gives me 70 there, 70 people. Okay. So so that's one way to solve it. The other way to solve it is to take this quadratic and put it in standard form and then complete the square to find the vertex. So let's do that. We're going to put this in standard form, and I'm going to bring this up right here and just copy it out and show you completing the square. So r of x is equal to x multiplied by negative 1.5x plus 210. Very easy to expand this into standard form. We would have negative 1.5x squared, that's this, plus this. plus 210x. Okay. Now we have a quadratic. It is in standard form. Let's put it into vertex form by completing the square. The first thing I do is factor out this negative 1.5 from the x terms. I have no c term here to worry about. So that's equal to negative 1.5 multiplied by x squared minus 140 x. Okay. Oops. Negative 140x, because 210 divided by negative 1.5 is negative 140. Check your calculator. All right. So now I bring this down, another equals, and I'm going to take half of that and square it. I'm going to look for my Jerry Maguire number. So let's just do our Jerry Maguire number hunt down here. Negative 140 divided by 2 squared is equal to 70 squared is equal to 4,900. 4,900, yes. So there is 70 squared. So I'm going to add that and subtract it. So negative 1.5 multiplied by x squared minus 140x plus 490 minus 490. Oops, I need more space. I'm going to bring my next equals over here. Just rewrite. Just do it on a new page, Mr. Jennings. So you'll notice I like to spread my work out over many pages. Let's just copy out what we had. R of x is equal to negative 1.5 multiplied by x squared minus 140x. I'm going to add that Jerry Maguire number, 4900, and subtract the Jerry Maguire number, 4900. And then I don't have a c term here that I have to keep track of. So that's finished. So now I can recognize that this here is a perfect square trinomial. So I have negative 1.5 multiplied by x minus 70 squared. So there is my x value. That's the x value of the vertex, and it happens to be 70 here. Okay, and so that means when 70 people attend, this achieves its vertex. And that's the same thing we found when we used the factoring method. Okay, and then I have the plus 49,000 is already in there. But now I have to take this negative 49,000, multiply by this a, and bring that outside. Okay, I have to remember that up here, I'm taking this number and I'm multiplying that one. So as I bring this outside of the bracket, I have to do a multiplication. So 4900 multiplied by negative 1.5 is 7,350. 7,350. Check your work with a calculator when you make that sort of noise. So yeah, 7,350 plus 7,350. Okay. The advantage of doing it this way is this tells me the vertex. This tells me that the vertex happens where x is 70, because 70 minus 70 is 0. Or I can just take this and flip the sign, so positive 70. Therefore, 7,350 is the vertex. Because a is a negative number, and some of you wanted to know, when does a parabola have a maximum? When does it have a minimum? It's just the value of this a. So here I have a parabola with a negative a. I know that that's an umbrella shielding you from rain. It's not a bowl collecting rain. A bowl collecting rain will have a positive a. This has a negative a, so a sketch of it looks like this. Whee! And this is the vertex. That's the point 70, 7,350. So therefore, 70 guests maximize the revenue, which is $7,350. So when they have 70 guests, that's when their revenue is the maximum. After 70 guests, the amount that each guest pays goes down so low that the revenue starts to drop again, even though they have more people to charge. Before 70 guests, even though the guests pay more, the number of guests just isn't large enough to generate as much revenue at 70. It's the competing force of the two lines that are being multiplied. What lines? these lines over here. X is a line. R, like, that's the number of people that come. That's just the line y equals x. And this line here is another y equals mx plus b. We're multiplying two lines. The biggest value we get is where they're both the biggest. So that's how I use completing the square to solve questions like that one.
Somebody here want to be on CCIM? Just a quick interview.
So this is how we take a look at completing the square to solve an applications question. Let's do another one. So this next one, the power P in watts produced by a solar panel is given by the function power is a function of I, representing the current, is equal to -5 times the current squared plus 100 times the current in amperes. What value of current maximizes the power? Okay, and then we're also being asked, what is the maximum power? So this is an application question, but we didn't need to invent our own function for that one. We're told that function. It's P of I is equal to -5 I squared plus 100 I. I also have no C value here that I have to keep track of. So I could solve this in one of two ways. I could factor out the I, and that would give me a situation where, and I can recognize that because I have a negative A, that I have another parabola that opens downwards. Also, because the C value is 0, I know that it touches the y-axis at the point 0, 0. So it also has a 0 there at 0, 0. 0 current, 0 power. But the power grows until the current becomes too great and it starts overpowering the power, and there's another 0 over there. So I could factor, find out where this is, and then that way I can determine the vertex. But let's practice completing the square. Okay, so if I want to complete the square here, my first step is I put a bracket around my I terms. If I had a C here, I would leave that on the outside of the bracket, but I have no C. There's no C term there. So to factor that -5 out, I would have -5 multiplied by I squared plus, minus 20. Careful that you don't make a sign error. Minus 20I. Okay. Now I use this to get my Jerry Maguire number, the number that will complete this square. So I do that over here. -20 divided by 2 squared is equal to 100. 20 divided by 2 is -10. -10 squared is positive 100. So I'm going to add and subtract 100 inside this bracket. This is equal to -5 I squared minus 20I plus 100 minus 100. Okay. Now, I recognize that this is a perfect square trinomial. This is equal to -5 multiplied by I minus 10 squared. I get that from this. -20 divided by 2 is -10. I can just put that number in there. So I know that this is happening at the point, oh wait, no, this is the vertex. This is happening at the point 20. Okay, when I is 20, this would be 0. So anyway, -5 I minus 10 squared, and then I need to, so actually that 100 is in there, but this 100 has to come outside the bracket, so I have -5 times -100, that's positive 500. Okay, sure thing. This tells me that this point here is the point 10, 500, and that tells me the answers to A and B. The value of current that maximizes the power is 10, because I represents current and 10 is the vertex, and that's the maximum value for this parabola. The maximum power is 500. That was 500 watts, right? That's 500 watts of power. Therefore, the maximum power happens at 10 amperes, and it produces 500 watts of power. Oops, there, produces 500 watts of power. So that's how you would use completing the square to find that point. If we had instead factored, we would have found that that point is the point 20, 0. Okay? And then we would have taken the average of those and found 10. And then we would have said, well, the vertex is right up in there. The reason why you can do that is because these are symmetrical. They're symmetrical around the vertex, or around that axis of symmetry. Okay? And up here, when you look, if you factor out the I and the -5, you would get negative 5I multiplied by I minus 20. So I minus 20, so when I is 20, that's also a 0. And then you would have averaged and found that. You can do those in one of two ways, but I wanted to review completing the square for you. All right, everyone, I hope that gives you a bit of review on completing the square, as well as how we use quadratics in several types of applications, both from physics and from business. Bye for now, everyone.